Hello, everyone. So here we are with binomials 2, and that's going to be, I believe, assignment 78. That's the last of the new material that I've sketched out, and depending on your pace, you either made it this far or you're going to go further. And hopefully Mr. Paz will take you into conics after this. Okay, so what are we doing in binomial 2? Well, let's sort of practice what we got from the last video. Here's your bell work problem. How about 3x minus 2y to the fifth? Okay, please do that binomial expansion. Okay, fifth. So 1, 5. I know, you really need it now, don't you? I do. 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay. So this is going to be 1 times 3x to the fifth minus 2y to the 0 plus 5, 3x to the fourth minus 2y to the first plus 10, 3x to the third minus 2y to the second plus 10, 3x to the second minus 2y to the third plus 5 times minus 3 times 3x to the first minus 2y to the fourth plus 1 times 3x to the 0 times negative 2y to the fifth. All right, so can we tidy this up? Sure, I'll tidy it up down here. 3 to the fifth is 243 times 1. So 243 x to the fifth. I've got negative 2 times 5 is negative 10 times 81, negative 810, x to the fourth, y to the first, plus 4 times 27 is 108 times 10, 10, 80, x to the third, y to the second, plus, now it's going to be minus, isn't it? Because it's minus 2 to the third, which is minus 8, times 9 is negative 72, times 10 is minus 720, x squared, y to the third, plus 16 times 5 is 80 times 3, 240, x, y to the fourth, and then finally 1 times negative 32, y to the fifth. Okay, nice. We can do these expansions. Fabulous. So here's what we're talking about today. What if instead of the whole expansion, we just wanted the third term? Okay, third term. So I know that the third term. So 0. Sorry, 1 second. Third term. Yeah, it's funny. I know it. That one. Yes, 2. Great. Okay, sorry. Just needed to remember things for a moment. So the third term is this one. This was a combination of 5 choose 2 times 3x to the third times minus 2y to the second. Okay, so this is my third term. And what I notice here is these powers have to add up to that. And these values are the same. For figuring out this coefficient, if I'm not using Pascal's triangle but combinations, these numbers are the same. Okay, so these are the same. These add up to this. Okay? So the sixth term. What's the sixth term? The sixth term is good. Oh, I don't have sixth term. The fifth term, combination of 5, choose 5, 3x minus 2y. Remember, these numbers are the same, and these numbers have to add up to that. So there would be my fifth term. Okay, so I think I have a little rule here. Let's just do, another one. Ooh, let's make that a 7. So how would you do the third term here? Well, I'd say a combination of 7, 3 times 3x minus 2y. This and this are the same, and this plus this should add up to that. Third term. Yes, I do want you to, make a numerical calculation and figure out what a combination of 7, choose 3, times 81 times negative 8 is. So we've got 7 math probability, choose 3, 35 times 81 times negative 8. Times 81 times negative 8. And I get 2 minus 22680, x to the fourth, y to the third. Cool. So that was the third term. Can you find now for me the sixth term? I'd really like it if you found me the sixth term. So what changes here? Sixth term. So that's going to be a 6. That's going to be a 6. And these need to add up to that. So that's going to be a 1. So I'm going to have 7 times 3 times 2 to the 6th is 64. So I've got 21 times 64. And that gives me 1344 x to the first, y to the 6th. Sixth term. Okay? And so if you're going to generalize a rule here, you might say, and choose r times x to the, hold on a second, I always have to do that later, y to the r, and this one was n minus r. There we go. And so that's our little sort of rule. So if someone says, hey, can you help me out, buddy? We've got 4x minus 3y to the 10th, but they're trying to find the coefficient on the term x squared y to the 8th. What's this number going to be? Well, if this is 8, this is 10. This is 10 minus 8. So I'm going to have a combination of 10, choose 8, times 4x to the n minus r, 10 minus 8, times minus 3y to the x power. So what does that get me? Well, that gets me 10, choose 8, 10, math, 8 times 16 times negative 3 to the 8th. Wow, it's going to be a big number. To the 8th. And so I end up with 472,392 x to the second, y to the 8th. See, don't even need to do the whole expansion. I could find any term. And that's what I'd like you to do now. Okay, so I've demonstrated a couple. Here's another one for you, 3x minus 2y to the ninth. And I want to know the coefficient on the x to the fourth, y to the fifth term. Okay, so pause the video and give that a try, please. So we know this is going to be a combination of 9 choose 5 times 3x to the fourth times minus 2y to the fifth. Now I want to say that students usually get this on the test, but because they're looking at something like this, they don't write the 3x and raise it to the fourth. And really you need to, because you need an 81 times a negative 32 times this number to get that coefficient. Just like this negative 2y, yeah, it's not just y to the fifth, it's this whole expression to the fifth. So a combination of 9, oops, not load, but math, 9 choose 5 times 81, 3 to the fourth is 81, times negative 2 to the fifth is minus 32. And I get minus 3, 2, 6, 5, 9, 2, x to the fourth, y to the fifth. See, I do get x to the fourth, y to the fifth, but only because I took that 3 and raised it to the fourth, and I took that minus 2 and raised it to the fifth. So don't lose those, please. Okay. One or two more? How about this one? 2x minus 3y to the eighth, and I want the coefficient on x to the sixth, y to the second. Give that a try, please, and we'll go from there. All right, so we know this is going to be a combination of 8 choose 2. There's the 8, there's the 2, times 2x to the sixth times minus 3y to the second. Okay, 8 choose 2 times, that's by the way 20, 8 times 2 to the sixth, which is 64, times negative 3 squared, which is 9. And I get 1, 6, 1, 2, 8, x to the sixth, y to the second. Nice. Hey, how is this problem different from the last three we just did? What if we have x squared plus y to the 10th, and we're looking for the coefficient on x to the 8th, y to the 6th. Now, I think this is a little different because in the other ones that we looked at, for example, this last one, ax to the 4th, y to the 5th, I'm sorry, this was 6, and this was 2. And over here, we had 2x minus 3y to the 8th. And we said, these powers add up to that. Well, these powers don't add up to that. How come? And how come is because I got that. Okay, so I'm still going to do a combination of 10, choose 6. Great. Times x squared to the something times y to the 6th. These have to add up to what? 10. 10. So this is a 4. 2 to the... Oh, when I raise a power to a power and multiply them. That's why. So, 10, choose 6. And that gives me 210, x to the 8th, y to the 6th. Okay. One more like that? Sure. This one's for you. X squared plus 3 to the 12th. And I want ax to the 8th. It's interesting, isn't it? So, give it a try. Come back when you're done. Hey, how did it go? So I'm thinking about a combination of 12 choose. Yeah, hold that thought. X squared to the, not sure, times 3 to the, oh, interesting. Okay, so I know that this plus this equals that. And I know that this is this times that. Okay, so that's a 4. And if that's a 4, and these have to add up to 12, this is an 8. So this is an 8. Want me to do that again? Okay, so I'm saying, hey, x squared has to be raised to what power in order to get 8? When I raise a power to a power, I multiply, so 2 times what is 8? This is 4. We know that these have to add up to that. And we know that this is always the same as that. There we go. So, combination of 12, choose 8, 495 times x to the 8th times 3 to the 8th times 6561. But wait a minute, I have number times number, so let's multiply by 495, and we get 3247695 x to the 8th. All right. But one last thing I want to do with, yeah, maybe 2. So, how about, you're going to love this part. All right, maybe not at all, but we're going to do it anyway. C to the 2/5 plus C to the 4/5 raised to the 25th power. I would like the first 3 terms. I'm not making Pascal's triangle to the 35th row, to the 25th row. But I do know that a combination of 25 choose, combination of 25 choose 0 is 1. And I know a combination of 25 choose 1 is 25. And so really I only need to find 25 choose 2 with my calculator. So 25 math probability choose 2, and I get 300. Okay, so what's my expansion look like? Well, the first term, combination of 25 choose 0, C to the 2/5 and C to the 4/5. Now, this is that power. And this power plus this power has to equal 25. So there's the first one. Plus combination, 25 choose 1, C to the 2/5 goes down 1, C to the 4/5 goes up 1, plus combination of 25 choose 2, C to the 2/5 23, because this is going down 1, C to the 4/5 squared. So that's what they are bulked out. Now we're going to have 1 times 1. Now here, these are 5s. So I can cancel 5, 5, and I get 2 times 5 is 10. So C to the 10th plus, this is 25. Here we have C to the 4/5. And what about here? Well, I got 48/5. Oops. C to the 48/5. Hey, and if I'm multiplying and the bases are the same, can't I add these exponents? So 4 plus 48 is really going to be 52/5 plus 300. And then what do we have? We have 2/5 to the 23rd. So that's 46/5 times C to the, raise a power to a power, I multiply 8/5. Oh, look, I can add those together, and I'll have 8 plus 46 is 54/5. C to the 54/5. And so there are the first 3 terms. guess what? It's your turn. Here's yours. X to the third plus 5x to the minus 2 raised to the 20th, and give me the first 3 terms. Pause the video, give that a try. Okay, so combination of 20, choose 0 times x to the third to the 20th times 5x to the minus 2 to the 0, plus a combination of 20, choose 1, x to the third, 19, 5x to the minus 2 raised to the 1, plus a combination of 20, choose 2, x to the third to the 18th times 5x to the minus 2 raised to the second. All right, well, let's figure out what that is. 20 math herp. Let's do that. Yes. I've got 20. Choose. It's 1. Excuse me. 22. It's going to be 1 there. All right. So when I raise a power to the power, I multiply. And stuff to the 0 power is 1. So I have 1 times 1 times x to the 60. So x to the 60 plus 20 times 5, right? Because that 1 has to come here and here. So I've got 5 times 20, which is 100. I've got x to the 57th times x to the raise a power to a power and multiply. 57 minus 2, right? Because I'm multiplying and the bases are the same, so I can add those exponents. This becomes 55 plus combination of 20, choose 2 was 190. 3 times 18, I believe, is 54. Yes, x to the 54th times, I forgot this, 25 times x to the minus 4th. So 25 times 190 is going to be 4750. And then when the bases are the same and I'm multiplying, I can add those exponents. That's a minus 4. So I'm going to have x to the 50. Okay, so we've got 4750 x to the 50. And there's our expansion. Okay. How about instead of the first 3 terms, you do the last 3 terms? How would this change if I wanted the last 3 terms? Well, this will keep ticking down until I get to 0, and 1, and 2. And this plus this have to add up to 20. So it's going to be 20, 19, 18. These add up to 20, these add up to 20, these add up to 20. And over here, remember this and this are the same. So that's 18, that's 19, and that's 20. Okay, so let's do this. This is going to be 190 times x to the 6th times 5 to the 18th. Kukla, 5 to the 18th. No way. Well, I'm glad you can set it up, and no, I'm not going to ask you to do 5 to the 20th either. I bet Mr. Boz won't either. Okay, great. The last thing I want to look at is, for those of you moving on to calculus, difference quotient. We saw the difference quotient in pre-cal in our functions unit. And so there's going to be this thing, this difference quotient, that we run into pretty early on in calculus. And so if I'm looking at f of x equals x to the 3rd, well, that means when I take this f of x and use it here, I'm going to have x plus h to the 3rd minus x to the 3rd over h. Well, that used to be quite a trauma for you to FOIL that out. Now you should be able to say, okay, x to the third, h to the 0, plus 3x squared h to the first, plus 3x to the first h squared, plus 1 times h to the third. If I expand this, there it is. And now I'm subtracting x to the third. Oh, well, that's my x to the third. So that goes away. And I'm left with 3x squared h plus 3x h squared plus h to the third all over h. And notice how each of these has an h in it. I can factor out an h on top. 3x squared plus 3x plus, 3xh plus h squared. And so then when I do, I can cancel that x with that, that h with that. And so my answer would be 3x squared plus 3xh, h plus h squared. And next semester, we're going to make h go away, so your answer would be this. Kind of cool. Will you go through that process of using the difference quotient when you have x to the fourth? And that'll be the last thing we do. In a video of new stuff. So, give it a try. Hey, so remember, we want to evaluate f, that's this thing, at x plus h. So that's going to be x plus h to the fourth minus x to the fourth, all over h. Luckily, you know how to do binomial expansions now, and so you're going to have 1 times x to the fourth plus 4 times x to the third h plus 6 times x squared h squared plus 4x h to the third plus h to the fourth all over h. Oh, don't lose that, minus x to the fourth. Yeah, if that f of x doesn't cancel away, you've made a mistake. I notice that all of these have an h, so I can cancel out an h on top and bottom. And so what I'm left with is 4x to the third plus 6x squared h plus 4x h to the third, plus h to the third. And there's my answer. All right, well, I'm sorry I couldn't be in the room with you today. I really appreciate how hard you worked. I think those of you who really pushed yourselves are going to find that college is doable, and those of you who kind of blew things off this year, or who were really challenged this year with this modality, those might be indications that you need to think about how you're going to compensate for those things if you go off to college and college finds you still in pandemic, or even if it's just regular college and you now suddenly have a lot of work. I will say that I've had a number of former students come to me and say, hey, Mr. Cookie, you know what you should always tell all those kids who are seniors in pre-cal? Yeah, you should tell them that they're idiots for not taking more classes and not taking harder classes. No, I kid you not. It's not the kids in calculus who say this as seniors. It's the kids who are in pre-cal as seniors who then go off to like the U of A and suddenly, whoa, heavy load, wow. And so those kids who took 4 classes their senior year, yeah, suddenly they feel way overwhelmed and that they had taken it way too easy. So keep that in mind, breathe, and step up to the work, and you'll be fine. Okay? All right. Have a fabulous day, everyone, and let me know how things go. Take care.